IPv4 addressing. In this video, I am going to talk about IPv4 address. You know that in TCP/IP network, each system, each host has one logical address. We call it IPv4 address. IPv4 address has 32 bits, and in most cases we are using the dotted decimal notation for representing the IPv4 address. We have learned about the conversion from decimal to binary or from binary to decimal in the CCNA class, and also we have learned about the 5 address classes of the IPv4 again in the CCNA class. For example, you know that in IPv4, we have 5 classes: class A, class B, class C, class D, and class E. And all of the addresses in class A are starting with 0. You know that class of each IP address, okay, can be found by verification of the first octet, okay? Because of that, if in the first octet we see 0 in the first bit, that address is a class A address. If we see 10, that address is a class B address. If we see 110, okay, that address is a class C IP address. And if we see 1110, okay, that address is the class D IP address. And finally, if we see quad 1 at the start of one IP address in the first octet, that address is a class E IP address. And here you can see the network numbers in each range. For example, in the class A, we have 1.0.0.0 to 126.0.0.0. Actually, here we should start from the 0 to 127, and you know that 0 and 127, for example, were reserved. I will explain them again. In class B, 128 to 199, actually 128.0 to 191.255. Then in class C, 192.0.0 to 223.255.255. Okay. In class D, from 224.001 to 239.255.255.255. And in class E, 240.0.0.0 to 254.255.255.255. Here we have some details that you should remember, all of these details, because this topic is under coverage of the ENSLD. We should review all of the details that here we have. For example, how many bits in each class A, B, or C are network numbers, and how many bits are host, for example, bits. Okay, we should talk about them. Actually, I'm going to use the CCNA video that I have created before for this part. First, in the CCNA video, we will review the topic of the conversion of the decimal to binary or binary to decimal. After that, we will review about the IPv4 address classes and some topics like the unicast communication, multicast communication, broadcast communication, or unicast address, broadcast address, multicast address, and also some other detail. Don't forget, if you have learned these topics in the CCNA class, it is recommended to review all of these topics in this video. Okay, and if it is new for you, it can be so informative for learning about the IPv4 addressing. Let me to use the CCNA video related to the IPv4 addressing, and after that, in the next video, we will continue to learn about the IPv4 addressing. In the real world, in the for example, in the world that we are living at, we are using the decimal basis. Okay, decimals means all of the numbers are in base of 10. Okay, base of 10. Let me to give you one example. For example, when you say 156, okay, this means that you are using this value 1 multiplied to 100 plus 5 multiply to for example 10, and also the 6 multiply the 1. This is the 156. Okay, and if I write this for example parameters in the base of 10, I can say that 1 multiply 10 to the power of 2, okay, after that 10 to the power of 2, after that we have 5 multiply again 10 to the power of 1, 10 to the power of 1, and after that for example 6 multiply 10 to power of for example 0. As you can see here, we have a value 156. We are using it in the real world. For example, you can say $156. Okay, and this means that you say you talk about the 1 multiply 100, 5 multiply 10, 6 multiply 1. Okay, and this is equal with the 1 multiply 10 to the power of 2, 5 multiply to 10 power of 1, and plus 6 multiply 10 to power of 0. Okay, as you can see, we are using the powers of the for example 10. This is the first, this is the second, and this is the third. Because of that, we can say that we are using the binary, the decimal basis in the real world. Let me to give you another example. For example, let me here, I'm using this value 1234. Okay, this means that, let me to write here 1 multiply 1000, and then 2 multiply 100, and then 3 multiply for example 10. Okay, and after that 4 multiply 1. This is the for example, this is equal with this value. After that, let me to use the copy this function here. First, we have the 1 multiply, okay, 1 multiply 10 to the power of 3, okay, and then after that we have 2 multiply 10 to power of 2, and then 3 multiply 10 to power of 1, and finally 4 10 to power of 0. Okay, this means that again when we say 1234, we are using the basis of 10. Look at here, this is the first, this is the second, and also this is the third, and also this is the fourth. Okay, this means that in the real world we are using the decimal. This is the decimal. Okay, and the decimal is the easiest method for us for using in the normal communication or normal numbers in the real world. This is the selected basis that we are using, decimal. But in the computer world, we are using another basis, binary. Okay, in decimal, as you know, in decimal value, let me to write here, in decimal value, we are using this number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These values, okay, are the values, are the numbers that we can use in decimal, okay, in decimal word. But here we have another word, another basis of the IP of the addressing. We call it binary. In binary, we have only 0 and 1. And when you say that I am using the binary basis, this means that you are talking about the basis of the 2. Okay, 2 to the power of something. Let me to give you one example for better understanding. Assume that we have 156 in the base of 10. You know that this is the base of 10. Here we can use the parentheses, and after that we have an annex. Here this means that 156 with the annex of 10. Now the question is that how you can convert this value, okay, to the binary, okay, and binary is the base of 2. This is the binary. When you say binary, means I'm using the base of 2. You need to write this value in the power of 2. What is the power of 2? Let me to review this for you. 2 to the power of 0, okay, equal 1. 2 to the power of, for example, 1 equal 2. Or 2 to the power of 2 is equal 4. 2 to the power of 3 is equal to the 8. You know it. 2 to the power of, for example, 4 equal to 16. 2 to the power of 5 equal to 32. Okay, 2 power of 5 equal to 32. Then 2 to the power of 6 equal 64. 2 to power of 7 equal to 128, and so on. Okay, how you can write the 156 in the power of 2? Okay, for example, we can say the 156 equal to the 128 means a 2 to power of 7. Okay, we don't use 2 to the power of 6 because if you add this value to the 128 you have a bigger value than the 156. But if you use the 2 to the power of 5, 32, totally you will have 160. Because of that, again, I'm not going to use this value, but we can use this value. 128 plus 16 equal is 144. Okay, again I can add the 8, 152 is the total. Okay, and after that we have a 4. Let me to add this value to each other. 128 plus 16 equals to 144. Okay, plus 8, 152, plus 4, 156. This means that if you want to use the binary values for creating the 156, you can use 1, okay, 1, 2 to the power of 7. Okay, let me to write here 1 multiply, I can use here 1 multiply 2 to the power of 7. Okay, this is the first value, and you know that we don't want to the power of 6 to power of 6. Because of that, let me to use 0 to the power multiply to the power of 6. And then also, as you saw, I didn't use 32 because of that 0 to the power of 5, but I used the 2 the power of 4. Because of that, we need 1 multiply to the power of 4, and also I used to the power of 3. Because of that, we need 1 multiply to the power of 3, and also I used to the power of 2. Because of that, we need 1 multiply to the power of 2. I didn't use 2 to the power of 1. Because of that, let me to use 0, 2 to the power of 1. Okay, and after that I didn't use the 2 power of 0. Because of that, let me to use 0, 2 to the power of 0. That's it. Okay, now this is the binary for example values of the 156. When you know that when we are using the decimal, we use these values. Okay, for the decimal value 156, 156, also 1234. And these are the factors of the power of tens. The factor of power of tens is 1, 5, 6. Here is 1, 2, 3, 4. Okay, here also we need to use the factors of the power of twos. For example, when you want to write the power of 2, here we have the 1, the first factor, and also and the next is 0. After that, the next is 0, then 1, then 1, then 1, 0, 0. Okay, this is the binary value of the 156. Look at here, 1 multiply to the power of 7, 0 multiply to power of 6, 0 to the multiply to 2 power of 5. Okay, again 1 multiply to the power of 4, 1 multiply to 2 power of 3, and 1 plus 1 multiply to the power of 2, and 0 multiply to the power of 1, and 0 multiply to the power of 0. This is the binary value if you use the factors. Here I use the factors. Here we have 8 bits, 1, 0, 1, 1, 1, 1. As you can see here, we are using only the 1 and 0 because of that this is binary. When you say that I'm using the binary basis, this means that you are using only the 0 and 1 in your number. Also, after that, you are using the factors of the power of 2. Let me to give you another example. These examples are important for us, but before that, look at here, decimal to binary conversion, base exponent 2 to power of 7, is equal to the 128 to the power of 6, equal to the 64 as I mentioned before, 2 to the power of 5, 32 to the power of 4, 16 to the power of 3, 8 to the power of 2, 4 to the power of 1, 2 and 2 to the power of 0 is 1. And here we can see the conversion of 35. Let me to use the conversion of 35 here. Now we can easily calculate the 35. You know that in 35, okay, we don't have for example 128. Because of that, let me to use 0. This is the factor. And after that, we don't use the 2 to the power of 6, 0. We have